Top 25 Platform Engineer Interview Questions and Answers. This guide provides essential platform engineer interview questions with clear, structured answers to help you prepare confidently, demonstrate expertise, and succeed in various technical evaluations. 1. What is the role of a platform engineer? A platform engineer designs, builds, and maintains scalable infrastructure that supports development, deployment, and operational processes. They focus on automation, reliability, observability, and system performance. Their work ensures engineering teams can ship software efficiently using stable, secure, and repeatable environments. Platform engineers integrate tools, manage cloud resources, and enable self-service platforms that reduce friction across teams. Their responsibilities span CI/CD pipelines, IAC, monitoring, and system optimization. 2. What skills are essential for a successful platform engineer? Core skills include cloud infrastructure management, scripting, automation, and proficiency in DevOps tools. Strong problem-solving abilities, understanding of CI/CD, and experience with containerization are crucial. Platform engineers must also understand networking, compute resources, observability tools, and configuration management. Strong collaboration skills help them work effectively with developers, security teams, and operations. Additionally, they should understand scalability patterns, system architecture, and reliability engineering to maintain efficient, secure, and resilient environments. 3. How do you approach building a scalable platform? I begin by evaluating system requirements, traffic expectations, and architectural constraints. I use cloud-native tools, load balancing, autoscaling, and distributed design principles to achieve scalability. Observability guides optimization decisions, while infrastructure as code ensures repeatability. I also test platform behavior under stress to identify bottlenecks early. Continuous monitoring and iterative improvements ensure the platform grows safely with business needs, preventing performance degradation and ensuring stability across environments. 4. What is infrastructure as code and why is it important? Infrastructure as code automates infrastructure provisioning through version-controlled definitions rather than manual setup. It increases consistency, reduces human error, and enables easier collaboration and repeatability. Tools like Terraform or CloudFormation help manage cloud resources efficiently. IAC supports scalable environments, rollback capabilities, and automated workflows. Adopting IAC also improves disaster recovery, environment parity, and operational efficiency. Its automation benefits save time and ensure stable, predictable infrastructure deployments. 5. How do you improve platform reliability? I implement monitoring, observability, automated alerts, and resilience patterns like retries, circuit breakers, and failover strategies. I use infrastructure redundancy to reduce single points of failure. Policies like chaos testing and load testing validate reliability under stress. Automation enables quick recoveries and predictable deployments. Error budgets and SLOS help align reliability with business needs. Finally, continuous improvement, documentation, and collaboration keep systems stable and evolving efficiently with organizational changes. 6. What is your experience with CI/CD pipelines? I design, manage, and optimize CI/CD pipelines using tools like Jenkins, GitHub Actions, and GitLab C. My experience includes automating builds, tests, and deployments for different environments. I integrate security scanning, artifact management, and rollback processes. I ensure pipelines are efficient, modular, and self-service. I also monitor pipeline performance to reduce bottlenecks. A well-maintained pipeline helps teams deploy faster, improves quality, and supports reliable continuous delivery. 7. How do you ensure system security at the platform level? I use encryption, identity and access management, network segmentation, and secure configuration baselines. I enforce least privilege, audit logs, and automated compliance checks. Integrating vulnerability scanning and patching ensures systems remain protected. I adopt security as code practices to embed controls into pipelines. Additionally, I collaborate with security teams to align policies and respond to threats. A proactive, layered approach helps maintain strong, consistent security across infrastructure and applications. 8. How do you monitor platform health? I use observability tools like Prometheus, Grafana, ELK, or CloudWatch to track metrics, logs, and traces. Monitoring includes resource usage, latency, errors, and application health. I configure alerting policies with meaningful thresholds to avoid noise. Dashboards visualize trends that help identify issues early. Monitoring CI/CD pipelines and infrastructure components ensures complete visibility. Combined with periodic reviews, monitoring supports stability, performance optimization, and proactive troubleshooting. 9. What is containerization and why is it important? Containerization packages applications with their dependencies into isolated units that run consistently across environments. It ensures reliability, portability, and simplified deployments. Containers reduce resource overhead compared to virtual machines and support microservices architectures. Tools like Docker and Kubernetes help manage container lifecycles. Containerization accelerates development, increases scalability, and improves environment consistency. Platform engineers rely on containers to deliver efficient, predictable, and secure application deployments at scale. 10. How do you manage Kubernetes clusters effectively? Effective Kubernetes management includes implementing autoscaling, resource limits, and namespace isolation. I use declarative YAML configurations and GitOps principles for consistency. Monitoring cluster performance and optimizing workloads ensures efficiency. I manage networking, ingress rules, and security policies with care. Tools like Helm streamline deployments. I also ensure high availability, backup strategies, and disaster recovery mechanisms. Documentation and automation help maintain stable, predictable Kubernetes environments across all environments. 11. How do you reduce deployment failures? I implement automated testing, static analysis, canary releases, and rollback mechanisms. CI/CD integration ensures issues are caught early. IAC prevents configuration drift. Real-time monitoring provides visibility during deployments. Feature flags reduce risk by enabling gradual rollouts. Pre-deployment validations further prevent failures. Strong collaboration with developers ensures smooth workflows. These combined practices significantly reduce errors, improve stability, and increase deployment confidence across the platform. 12. What is your approach to logging and observability? I centralize logs using tools like ELK, Loki, or CloudWatch and ensure structured log formats. Observability includes metrics, logs, and traces for full visibility. I design dashboards and alerts that highlight performance anomalies. Correlation capabilities speed up troubleshooting. By integrating observability into CI/CD and infrastructure, I ensure rapid detection of issues. Observability supports reliability, proactive optimization, and efficient root cause analysis across the platform. 13. How do you manage secrets securely? Secrets are stored using tools like Vault, AWS Secrets Manager, or Kubernetes Secrets. I enforce encryption, rotation policies, and role-based access. Secrets are never stored in code repositories. Automated retrieval ensures secure access during runtime. I review audit logs and monitor suspicious activity. Proper secret management reduces risks and protects critical systems from unauthorized access. Maintaining strict security around secrets is essential for overall platform resilience. 14. What is your experience with cloud platforms? I have hands-on experience with AWS, Azure, and GCP services, including compute, networking, and storage. I build scalable architectures using managed services that reduce operational overhead. I use IAC for cloud provisioning and monitoring for visibility. I optimize performance and cost through autoscaling, right-sizing, and resource grouping. Cloud expertise enables building resilient platforms that align with business requirements. This experience supports secure, scalable infrastructure solutions across environments. 15. How do you handle incident response? I begin by assessing the impact and prioritizing severity. I use monitoring tools to identify root causes quickly. Communication with stakeholders ensures transparency. I mitigate issues through rollback or patching. After resolution, I conduct post-incident reviews to document findings and recommend improvements. Automation reduces manual errors. Lessons learned strengthen future responses. This structured method ensures rapid recovery, reduced downtime, and continuous improvement across the platform. 16. What is blue-green deployment and when do you use it? Blue-green deployment involves maintaining two production environments to enable instant rollback and zero downtime releases. I use it when stability and user experience are top priorities. Traffic is gradually shifted to the new version after validation. If issues arise, returning to the previous environment is seamless. This strategy reduces deployment risk, improves confidence, and ensures smooth transitions during critical updates or high traffic periods in complex systems. 17. How do you reduce cloud costs while maintaining performance? I optimize resource allocation, right-size virtual machines, and leverage autoscaling. I monitor usage patterns to eliminate waste and use reserved or spot instances. Using managed services reduces operational overhead. I implement policy-based governance to enforce cost controls. Optimization includes storage lifecycle policies and efficient architecture design. Regular reviews ensure cost-effectiveness without sacrificing reliability or performance. Balancing these factors ensures sustainable and efficient cloud operations. 18. What is your experience with GitOps? GitOps uses Git as the source of truth for infrastructure and applications. I use tools like Argo CD or Flux to automate deployments. GitOps improves consistency, enhances version control, and enables rollback. It simplifies collaboration and ensures declarative configuration. I've implemented GitOps for Kubernetes environments, improving reliability and reducing configuration drift. GitOps aligns well with modern DevOps practices, delivering predictable, automated, and secure platform operations. 19. How do you troubleshoot performance issues? I start by gathering metrics, logs, and traces to understand the system state. I isolate components to identify bottlenecks. Tools like profilers, monitoring dashboards, and load tests help pinpoint issues. I evaluate CPU, memory, I/O, and network behavior. Fixes may involve scaling, configuration tweaks, caching, or code optimization. After resolution, I validate improvements and update documentation. Structured troubleshooting ensures long-term stability and performance enhancements. 20. What is the difference between vertical and horizontal scaling? Vertical scaling increases resources on a single machine, while horizontal scaling adds more machines to distribute load. Vertical scaling is simple but limited by hardware. Horizontal scaling supports higher availability and distributed workloads. Platform engineers prefer horizontal scaling for resilience, microservices, and cloud architectures. Both strategies are used depending on requirements, cost, and system design. Understanding both ensures optimal scaling decisions during platform growth and performance planning. 21. How do you use Terraform in platform engineering? I use Terraform to provision cloud resources through declarative configuration files. It ensures reproducible, version-controlled infrastructure. Modules and workspaces help manage complexity and environments. Terraform enables collaboration through code reviews and predictable automation. State files track infrastructure changes, ensuring accuracy. I integrate Terraform with CI/CD pipelines for automated provisioning. Terraform enhances reliability, reduces manual errors, and supports scalable infrastructure development across platforms and environments. 22. What is your approach to platform automation? Automation starts by identifying repetitive tasks that slow development or operations. I use scripts, IAC, and CI/CD pipelines to automate provisioning, deployments, and monitoring. Automation reduces human error, accelerates workflows, and improves consistency. I ensure automation is well documented and maintainable. Testing automated processes validates reliability. Through continuous automation, teams gain efficiency, stability, and better control over platform behavior across all environments. 23. How do you support developers through platform engineering? I build self-service tools, templates, and environments that reduce friction. Clear documentation and reliable infrastructure empower developers to deploy independently. I integrate feedback loops to address pain points. I ensure CI/CD pipelines are easy to use and efficient. Monitoring insights help developers identify issues early. Collaboration ensures alignment with project goals. Supporting developers accelerates delivery, improves productivity, and strengthens engineering culture across the organization. 24. How do you manage configuration drift? I prevent drift using infrastructure as code, version control, and automated provisioning. Regular scans detect differences between desired and actual configurations. GitOps enforces declarative consistency. I avoid manual changes or document them thoroughly when necessary. Monitoring tools alert on unexpected modifications. Maintaining consistent environments ensures reliability and predictable behavior. Configuration drift reduction improves security, stability, and operational efficiency across the platform. 25. What makes you a strong candidate for this platform engineer role? My strengths include strong cloud expertise, automation experience, and deep understanding of infrastructure design. I excel at building scalable, secure platforms that empower developers and operations teams. My problem-solving skills, communication abilities, and hands-on knowledge of CI/CD, containerization, and observability make me effective in dynamic environments. I focus on continual improvement and collaboration. These combined qualities ensure I can deliver meaningful, reliable infrastructure solutions for your organization. These questions and answers build a strong foundation for interview success, helping you communicate skills confidently and demonstrate problem-solving abilities essential for platform engineering roles.